In this video, we're going to look at how to calculate the angle between a line and a plane in vectors. So before we solve this question, I'm going to explain visually what's actually happening in this scenario. So what we have is a plane, and we have a normal to the plane represented by n, and we have a line L, which is another vector. And what happens is we want to calculate the angle between the line and the plane. So what I'm going to do is to start off by drawing the same normal vector from the line down to the plane. And we know that's the normal vector n, which is done in blue. And we know it forms a right angle with the plane, hence it's perpendicular to the plane. So we know it's exactly at 90 degrees, so we can draw that in. And we're going to form a right angle triangle. So we draw the base in here, and we have a right angle triangle in question. Now, what's important earlier in this chapter, or in earlier videos, I would have talked about something called the dot product. And the dot product is the angle between two vectors. And what's important about this, when you got the angle between two vectors, which we're going to call alpha, the most important thing about this is both vectors must be going away from the points. And in this case, n is going away from the point, and line L is also going away from the point. And provided that both vectors are going away from the point, then the angle between them is alpha. Now, notice that the normal line vector here is parallel to the normal vector here. We have two sets of parallel lines, hence that we have alternate angles, meaning this angle is also alpha. Now, the reason why I've mentioned this is that the angle required we want is the angle between the line L and the plane, and this angle here is what we require, and we're going to call that theta. Now, theta is the angle we require, not alpha. So now let's take a look at the example. It says to find the acute angle between the line L with equation r is 2i plus j minus 5k plus lambda 3i plus 4j minus 12k, and the plane with equation r dot 2i minus 2j minus k equals to 2. So what we're going to do, we're going to start off by writing down what b is, and that's basically the direction vector of the line, hence 3, 4, minus 12, and the normal vector, which is n, in our case r dot n, which is the equation of the plane, in our case 2, minus 2, and minus 1. So let's write those down. So we're going to start off by writing that down. So we're going to say that b is basically my direction vector of the line, which is 3, 4, minus 12. And then we've got n, get that from the equation of the plane, which is 2, minus 2, and minus 1, respectively. Now, I always tell my students, especially in A-level further maths and even in regular A-level as well, to use column vectors. It's just a lot easier to write as opposed to writing IJK. Writing IJK, in my opinion, is just a lot more cumbersome and laborious as you're writing it, as opposed to writing column vectors, which is the preferred standard convention. So what I'm going to do now is to write down the formula that we need for the acute angle between the line and the plane. And that's going to be sine theta. Now this is important here, a massive modulus sign. And this here is called the mod. So it's the mod of b dot n over mod b times mod n. And it's a huge modulus sign. Now the modulus is important. The modulus always allows us to work out the acute angle, and the question states that to calculate or find the angle between the acute angle, more importantly, between line L and the plane. So we're going to start off with the dot product. So we're going to do that here. So we're going to say b dot n. So we're going to do a simple dot product. So it's 3, 4, and minus 12 dot with n, which is going to be 2 minus 2 minus 1, and that's simply going to be 3 times 2 plus 4 times minus 2 plus minus 12 times minus 1. So we can just simply type that into our calculator, and that's simply just going to give me 10. So b dot n gives me 10. Now I'm going to find the modulus of b. Straightforward Pythagoras here. That's just 3 squared plus 4 squared plus minus 12 all squared. So mod b gives me 13. Doing the same thing for mod n. Again, straightforward Pythagoras here. 2 squared plus minus 2 all squared plus minus 1 all squared. So mod n, don't forget to underline your vectors, just like what you do at GCSE, is in our case equal to 3. So now we're going to use the formula. So now let's write down the formula. So we know the acute angle between the line and the plane is sine theta, massive modulus sine b dot n over the mod of b times the mod of n. So in our case, sine theta is 10 over 13 times 3. I'm going to put a big modulus sign here. So we're just going to get sine theta is 10 over 39 respectively. Therefore, theta is arcsine. So theta is arcsine 10 over 39, for theta is equal to 14.9 degrees. 2, 3 significant figures. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So now we have a very similar question to what we did in our first example. So just to remind you again, this is what we have in terms of our diagram. I'm just going to put this back to remind you this is what the situation that we have and what we want. So what we're going to do is to first of all write down what b and n are respectively. So let's do that. So b is the column vector, which is the direction vector of the line, which is 4, 4 and 7. And then we've got the normal vector n, which we get from the equation of the plane, r dot n, which is 2, 1, minus 2. And don't forget, we're trying to work out b dot n. So we're just going to use simple dot products, 4, 4, 7. And we're going to times that. So dot it with, sorry, not times, dot it with 2, 1, minus 2. Standard dot product here. And we're going to do, now we're going to do 4 times 2 plus 4 times 1 plus minus 2 times 7. We can just type that straight into our calculator. So for b dot n, we're simply going to get minus 2. Now this is important. I alluded to earlier in the example saying that the modulus sign will eliminate the minus on the numerator, and it will always coerce to give the result of the acute angle, and that's what we want. So now we're going to say mod B is going to be 4 squared plus 4 squared plus 7 all squared. So mod B works out to be 9. So we've got that there, and I need to underline my vectors. Exactly what you do at GCSE. Same thing in A-level maths and further maths A-level. So mod N. So again, straightforward Pythagoras here. 2 squared plus 1 squared plus minus 2 all squared. Mod N works out to be 3. So now we're going to use the formula. So now we're going to say sine theta, a big modular sign, B dot N over mod B times mod N. And this will always, by default, give us the acute angle by using the modular sign. Now, this is quite nice because we have a minus on the numerator, which I put in brackets, minus 2, and 9 times 3 respectively. So in other words, we have sine theta is 2 over 27. The modulus has eliminated the minus, or got rid of that. So by default, the modulus will give us the acute angle. So theta is arc sine. Don't forget, if you're doing further maths A-level, you would know, and even the regular level students would know, that arc sine is the formal name in mathematics of sine inverse or cos inverse or tan inverse. So we always say arc sine, arc tan, arc cos. So more formally, it should always use formal notation in regular A-level and in further maths, especially in further maths as well, and in regular A-level, there's no difference. So being pedantic and solid in your working out is vital for the exam. So that works out to be, therefore, theta is 4.25 degrees, correct to 3 significant figures. And these are our examples of calculating the angle between a line and a plane in vectors.